y equals square root of x equals 0, x equals 4, revolve about the x-axis. Okay, this is where graphing knowledge comes in. What's y equals square root of x look like? Ooh, with sound effect. Like that?
Yep.
Okay, what's x equals 0?
A line
at 0. A stopping point.
Okay.
A vertical.
Wait, why did I say x equals 0? Okay, so x equals 0, what's x equals 4?
Vertical line at 4.
Vertical line at 4, yes? So essentially, what is it doing? It's doing that, right? I don't know why x equals 0 is even listed here, honestly, because x equals 0 would be the y-axis, which, I wonder if it's supposed to be y equals 0. I don't know. Okay, so, and we are revolving about the x-axis, okay? So you see the area we're talking about, right? We're talking about this piece here, revolving about the x-axis.
So it's kind of like a. It's kind of metal.
Yeah, I think of it kind of like a dome.
Oh yeah.
Like almost like a semi-sphere, but it's going to go farther.
Yeah.
A bowl, an upside down bowl. I could go with that.
Oh yeah. Well.
Yeah, you know. Well, I say upside down because my visualization is setting it this way. So I guess, you know, a bowl on its side, sorry. But on its edge.
Bowling down.
So, okay. With this in mind, since we are revolving about the x-axis, okay, that means we have this little representative rectangle here, right? I made that a little bit bigger than I probably should have, but that's what's revolving when we're revolving about the x-axis. Okay, because we're revolving about the x-axis, this rectangle is perpendicular to the x-axis. We're going to be working in terms of what?
X.
We're going to be in terms of x's, right? Okay, because this is something you have to be able to identify. And so when we talked about it yesterday, the distance from here up, we talked about it as being y, right? Because you're measuring up, that's a distance of y. Okay. It's also, as this rotates about, you can also think of this as your radius. Are you with me on that?
Yep.
Okay. So, with that in mind, if we talk about our volume here, volume of a cylinder is pi r squared h. We know we're going to use pi, right? R, well, what is R?
1.
Y.
We can talk about it being y, and then what do we use for h?
dy. dx.
Because that's the change in x, right? dx. And here's the deal. Are we working in y? No. What are we going to put in place of y? It's going to be the square root of x squared dx. Because what is y equal to? Square root of x. Are we okay with that setup?
Yes.
Okay. Well, let's go. Okay. So volume is the integral pi times square root of x squared dx. We already had that part, yes?
Mm-hmm.
Do you guys like Mario 0 to 4?
Yep. Yeah.
And those 0 to 4 are x values, right?
That's why they gave us x equals 0.
But even then, my argument as a calc teacher would be it intersects right there. So it ends right there. I don't know why. Whatever. Okay, that's the basic setup, yes? If I do a little cleanup, I can pull the pi out front. Integral from 0 to 4, square root of x squared, x dx. And this is piece of cake math at this point? No? We've got pi. Integral of x is 1/2 x squared. Evaluated from 0 to 4. Personally, pi times 1/2 in my brain is pi over 2. And so then I only have to evaluate with x squared. So plug in 4, plug in 0. 4 squared minus 0 squared.
16.
Pi over 2 times 16, which is
8
8 pi.
8 pi.
Okay, questions there? If only they were all this easy, right?
Yeah.
Okay, but that's a basic setup. Okay, that's a definite. We need to walk out of here knowing how to do this setup today. Okay, let's go ahead and do number 4. Y equals x squared, revolve about the y-axis from 0 to 4. Okay, so what's y equals x squared?
A parabola.
Parabola. Now, our brain says this for y equals x squared, yes? And I'll be honest, that's what I have drawn here. But officially it says from 0 to 4. So truly, what do we not really technically need?
The left half.
You don't need that left half. Okay? Now, as I said, I have it in mind. Because here's the deal. As it revolves, what's it going to do? It's going to spin around and it's going to overlap on that, isn't it? So that's why I'm going to argue that you could have that picture drawn as well. Okay? So y equals x squared from 0 to 4. About the y-axis. From 0 to 4 is 0 here and 4 where?
Up.
4 up. Okay? So right there's your idea. Okay. I mean, officially, I could just think about that as my shaded area, right? That's revolving. But it's going to revolve on top of the other piece, isn't it? So it doesn't really make a difference. Because we are revolving about the y-axis, what do you know? It's in terms of y, right? Because it's about the y-axis, we're going to be working in terms of y's. My rectangle that I'm rotating about is a horizontal, right? It has a length of x across, yes?
A height of dy.
And it has a width, it's change in y, so a width of dy, right? Huh? And it's also a radius, yes. Okay. It's also what we're going to think about as radius. Okay. And this graph was originally y equals x squared. Okay. Thoughts?
B equals. Is this very similar to the last one?
I think B
Yes and no.
equals pi y dy.
I mean, if we start talking about volume here, right? It's pi times,
R squared.
r squared h, okay? So pi, what's my radius?
X.
It's x. What's my height?
Dy.
dy. Now, we can't have x and dy in the same thing. X is just the representation that it's x across. What are we using in place? I forgot the squared. X.
Y.
Square root
There's just plain y because y equals x squared.
Yeah,
So
but
x
you
squared
do
equals
square root of y times squared, but we're splitting it.
Okay. We could argue it either way. I'm with you. Okay.
I did it different.
Okay. So what Doug's seen is y equals x squared. What is this right here? X squared. So Doug's saying that I could just make this y. Now, what did our brains probably go through first? If you didn't really catch that that was just going to be the same,
X equals the square root of 1.
if it's y equals x squared and we solve this, x is the square root of y. And so then what are you doing? Square root of y
Squared.
squared. Doesn't matter which way you go. No, especially in calculus. Calculus would be perfectly fine with what Doug did. Okay, the fact that he just saw it, that's perfectly fine. Okay? So, one way or another, we're there, right? So, v equals, what do you want to do?
And go from 0 to 4.
So you want to put the pi out front? You can. Now, keep in mind, the 0 to 4 are my y values, right? Okay, integral of?
Y dy.
Are you guys okay if I go ahead and do y dy?
Yep.
So, is this at the point, Sophie, that you say, is this very similar to the last one? Is this what you were asking?
Just the whole thing, I felt like it was almost the exact same thing. And
Well-
so then I felt like it was too easy.
Okay, and here's the deal. The square root of x and x squared are inverse operations. And so the fact that one's going around the x-axis and the other's going around the y-axis, yeah. So what's the answer going to be?
8 pi.
8 pi.
Because technically we're doing the same thing, but in terms of y's. So. So yes, it was very similar. Very, very similar. Okay. And as we look at these and we rotate these, I haven't really talked today, but we're rotating, getting one big circle, yes? So these are what we would call disk method, because there's one big circle. It's just one big flat disk that's rotating or being created, right? So just kind of keep that in mind as we proceed. Okay, you guys are ready for 5? Okay, start thinking about 5. I am erasing one of my graphs, so because I just don't have enough screens today. And there we have 5. Okay, y equals the square, y equals e to the x.
Is that the
No, it's.
What Hannah said, and she just told me. So.
I thought it was not mine. Yeah.
oh?
And then you go straight up. Yeah.
It's that. That's e to the x. That's 2 to the x. That's 3 to the x. That's 10 to the x. Okay? It's any number above 1 raised to the x. If you throw a number between 0 and 1, it flips it and goes the other way. Okay, so it's this, revolving about the x-axis. So that's this one right here, from 0 to 2. If it's saying revolving about the x-axis from 0 to 2, that's saying from 0 to 2. Okay, so that means that piece right there. So I'm looking at that piece.
Okay. Yeah. It is really weird. Oh, so it's kind of like a funnel-ish thing?
With a flat top.
Yeah.
Well, yeah, you're envisioning a hole in the middle, but yeah, I see. I could see that.
Okay.
You know. I think those videos did help you guys be able to see it a little bit. So, okay. And again, since we're rotating about the x-axis, there's the piece that's rotating, yes? Or there's a snippet of the piece that's rotating.
Y.
Okay, it has a height of y right there, yes? So this is going to be pi. If we want to just jump in, it's going to be y squared, and the width of this is dx. Now, what does y equal?
Yes.
Right? This graph was y equals e to the x. So that means we're doing e to the x, quantity squared, dx.
2x.
Okay, volume equals. What do you guys want to do?
Pi times the integral of 0 to 2.
Of?
E to the x pi
Dx. Now, this is important here, guys. It's technically basic exponent rules, but you guys have forgotten, maybe you guys haven't. Maybe I've reviewed them enough with you guys. But exponent rules just get forgotten after you guys leave middle school. For whatever reason, they get forgotten. So this is the integral from 0 to 2. Power raised to a power is multiplying. So it's e to the 2x. Okay? Now, There's two different ways I could argue we could integrate
Use
this.
substitution.
Okay.
Yeah.
Can we use substitution? Yes. Would you have to use substitution? Not necessarily. If you can see it, you would not have to use substitution.
So just
Okay.
2 to 2x.
Hold your thought. Now, and here's the deal. Everyone's different places. I'm going to use substitution, but I'll also talk about what it is here in a moment, okay?
Okay.
So, if we're using substitution, what is u going to be?
2x.
And if nothing else, we haven't done u substitution for a bit. So let's review it, yes? So if u is 2x, then take the derivatives. Derivative of u is du. Derivative of 2x, 2 times dx. Now, as I start looking here, here's going to be my u. I have dx, but do I have a 2? No. So what do?
Oh, yeah.
So you're going to divide.
I forgot.
And so now I have what dx is, yes? So now I can say, okay, it's pi. That's going to bug me. I picked a different color. It's pi, the integral. And then here we're going to say e to the u. And then what?
1/2.
In place of dx is going to be 1/2 du. So I'm going to say du, and then I'm going to throw in a 1/2 there. Yes?
Would you be able to?
Now, I don't show.
You can pull that 1/2 up front, right?
Yes, you can.
That's fine.
Definitely. Definitely. What I was trying to decide here is, okay. Okay. I know what I did. So here's the deal. If I put boundaries right here, I have an option. And this is where I was debating which way to go. If I put 0 and 2 here, 0 and 2 were boundaries of x. Now, it wouldn't be bad to go back to x's. Okay? Because here's the deal. Can you integrate this pretty easily? Yeah. Okay. The 1/2, Hannah was saying, pull it out front, yes. And actually, it can go out front with the pi. And so we can say that this is pi over 2. What's the integral of e to the u? E to the u. And then it would be evaluated from, now here's the deal. Do you want to keep it in u's or do you want to go back to x's?
Go back to x.
Just go back to
x's.
And in this case, I'm not against that. If we go back to x's, it's pi over 2 e to the what? 2x. And now you can officially say evaluated from 0 to 2. I don't like in my notes, I kept writing 0 to 2 the whole way. And I don't like that I did that. Okay? Because here's the deal. When it's u's, it's not 0 to 2. I think it'd be 0 to 4 if you kept it in u's. Okay? Now, Sophie, earlier, if we had integrated this, e to the 2x, the integral of e to the 2x is e to the 2x. And then you'd have to have a 1/2 out front to compensate for the derivative of 2x being 2. So if you just went from here to here, could you do this?
Yes.
Yes, if your brain is there. Okay? If not, use substitution as our backup, right? Okay. What do we got? Pi over 2 times e to the 4 minus e to the 0. Does e to the 0 matter?
Yes,
Is that 1?
it's 1.
E to the 0 is 1. So does that 0 matter this time?
Yes.
Most of the time?
No.
It doesn't matter. Does it matter on occasion? Yes, and here's your proof. So pi over 2 times e to the 4th minus 1 is probably how I'd leave the answer unless I'm told to use a calculator. Okay?
2 more pages to go.
Okay. We've got the basic disk method under control, right? Okay. So we talked a little bit already yesterday, okay? I showed you the one where there are 2 graphs. When it revolved, they're created. It wasn't solid all the way up against the axis, so there was a hole created in the middle. That is your washer method there, okay? Because there's going to be a hole created in the middle. So a washer or a ring. What we'll talk about here is a large outer radius, capital R, and a smaller inner radius, lowercase r. Okay, so you'll hear big R, little r. And in this case, the area of the single slice. So we've been doing pi r squared times the height, right?
Mm-hmm.
We're still going to do pi r squared, but what's going to happen is in order to get this radius right here, we're going to end up doing the outer one, so big R squared, minus the inner one, little r squared, is what we're going to end up doing. Okay, and so that's why you'll see pi times big R squared minus pi times little r squared. This is going to be your outside radius minus your inside radius is what's happening. Most often, you will see it as pi times big R squared minus little r squared. Okay? Here's your example of the washer, okay? If we're just wanting to find this ring here, okay? That's what we're looking at, is just finding this ring. You'd have to do the big R, which is your outside, and you'd have to subtract the little r, which is your inside. In this case, if we are rotating about and it looks like in the picture, the x-axis, the outside one is your f of x in this case. The inside one is your g of x. Okay, so it's kind of like, you know, how we think upper minus lower. Think farther from the axis minus closer to the x-axis. Okay? And I don't feel like that picture is very good because you can't see that it's hollow inside. You know, at least in my opinion. Okay. I guess the other thing I have listed here is the idea that, like, right here is big R, right here is little r. Okay? So you're always going to that axis you're revolving about. Now, some things aren't changing. To find the volume of a solid of revolution where each slice of the region to be rotated is perpendicular to the axis of the revolution, use the following formulas, okay? If it's a horizontal axis of revolution, okay, so like an x-axis, then you're going to be in terms of x. If you're rotating around a horizontal axis, so rotating around like an x-axis, it's in terms of x, and so everything's in terms of x. If you're rotating around a vertical axis, so that's like a y-axis, then everything is in terms of y. Okay? You ready to talk 6?
Yeah, let's get this over with.
Okay. Draw me a picture while I blow mine up. I need room to write here. What can I say? You drawing the picture, or you being lazy and waiting on me?
Well,
Is it up 1 half? Is that what it is?
yes.
Yeah, so f of x equals 1/2 plus x squared is what? Now, I'm going to make that half quite a big up half, just because of, think of it as we kind of need to zoom in on what we're seeing here. Okay? So I'm going to take my half to be quite up. But it's 1/2 up, and then the x squared is a parabola, yes? Okay? Now, officially the parabola goes this way too, yes? But what does it already say? From 0 to 2, which I'm not going to put my 2 on there quite yet. Or maybe I can. Oh yeah, what's my other graph? G of x equals x, and so that is
One straight line.
y equals x. That's y equals x. This is y equals x squared plus 1/2. And we're going from 0 to 2. So what's that going to matter? That's basically going to say, it doesn't say you have to draw the line there, but it's that section there. So we're going to take this, and we're rotating it about the x-axis. Is it clear to you that this is no longer a disk method? It's not going to be a solid, is it? Because there's a big gap here. Now, technically, it's not going to be a hole you can see all the way through, but there's going to be this big cone-shaped hollow piece, right? So this is definitely a washer method, because that's one of the things you're going to have to decide in homework. Is this a disk method or is this a washer method? They're not going to have them all grouped and just tell you.
It's a dryer method.
A dryer method. Ooh, okay, getting fancy here. Interesting. Okay. Let's see. So what we're looking at is this is the piece that's being rotated, right? This is the piece being rotated. It's going to have a width of what?
Why?
Well, width of dx is where I was going for. Okay. Mario, you're looking at the height of y, right?
Yeah.
Now, I'm going to think about it a little differently, though, because in order to get this y, what do we have to think about? We're going to have to think about the upper. So the upper being your big R minus the lower being your little r. Well, what is big R going to be here? Big R is going to be the x squared plus 1/2. What's little r going to be? Your x. Because we're doing this in terms of x, yes? Now, I was just going to go ahead and set it up. Here's what I got for you. V equals
The integral
the integral.
of 0 to 2.
And how do we know 0 to 2? Because they told us.
Oh,
Somewhere we need a pi, yes? Now, could you go ahead and plop it out front? You can. Can it be in the integral?
No.
They can.
no.
They can. It doesn't matter. Okay. So I'm just going to put it there for right now because I didn't. Okay. Now, bracket parentheses something. Okay. Remember when we do this setup? The setup is
Big R squared
big R squared
minus little r squared.
minus little r squared. Okay? What's big R? What's our farthest away function?
1/2 x plus x squared.
X squared plus 1/2 or 1/2 plus x squared. So x squared plus 1/2 quantity squared minus little r squared. What's little r?
X.
X quantity squared. In my brackets, dx. Do the math? What kind of math has to happen before we can proceed?
Something up in the middle.
Yeah. So I'm going to say pi times 0 to 2. What do you know about x squared plus 1/2 quantity squared?
That's 1/4 plus x to the now.
And
Oh. I don't do this right now.
okay. First, and the way I have mine set, if yours is backwards, we're just going to be in opposite order. It doesn't matter. X squared times x squared is x to the 4th. Outsides. X squared times 1/2 is 1/2 x squared. Insides.
1/4
X squared.
Insides are also going to be
1
1/2 x squared. What's 1/2 x squared plus 1/2 x squared?
x squared.
1x
yeah.
squared. Plus, that was outsides and insides. What's last? 1/2 times 1/2, which is 1/4.
Now it's 2/3.
minus, what else do we still have over here? X squared from little r. Write out the FOIL if you need to, folks. I could tell that one was a little rough. Now, if I go ahead and one more time clean up, what can I clean up? X squareds can cancel themselves out. Means I am only integrating two terms, right? X to the fourth plus a fourth dx. So if I integrate, add 1 to the power, divide by the new power, plus evaluate from 0 to 2.
Yeah.
The pi I keep carrying down because I'm afraid to lose it. 1/5 x to the 5th. Okay, if I put in 2, 2 to the 5th.
25.
No. That would be 5 to the 2nd. 2 to the 5th is 32. Divided by 5, 32 fifths. 1/4 times 2. 1/2. That's putting in 2. Minus
0 plus 0.
Yeah.
minus 0 and 0, yes? Did you at least confirm that in your brain? Even if you don't write it down, did you at least confirm it? So all I need to do is add 32 fifths and 1/2. Common denominator of 10. So 64 tenths plus 5 tenths.
69 pi over 2.
Okay. Okay. You did your first big disc method, or washer method.
Too bad. Better than
I mean, it takes a little bit more work. I mean, you know, that's the honest, but it's not horrible. Okay.
It takes a minute to get into this. It's like the beginning lesson is like, oh my god, I'm so bent up.
Okay. 7. Find the volume of the solid formed by the region bounded by graphs of y equals square root of x and y equals x squared about the y-axis. Okay, y equals square root of x is what?
Swoop.
That?
Yep.
Y equals x squared.
Parabola.
Parabola.
Yeesh. Now, I only drew first quadrant parabola because it's the volume of the solid formed by the region bounded by these graphs. Is square root of x going to be over here anywhere else? Square root of x is just a first quadrant graph. So what is the shape here?
Kind of a flower.
Efficient.
It's that little thing, yes? And we're rotating that little thing about the
Why?
y-axis, which means we're going to be working in terms of y's. Okay? So far, so good. Okay. Now, disc or washer method.
Washer.
So there's going to be a gap?
Yeah.
Yeah.
Because we're taking this, we're rotating this about, yes? Now, let's talk about big R and little r. What's big R going to be here?
X squared.
Because what is farther, we're rotating about the y-axis, what is farthest from the y-axis? That's going to be your big R. Now, it's officially x equals y squared. If we're working in terms of y, we're going to have to think x equals square root of y, yes? Just saying. That's going to be my big R. Little r is going to be the one closer to the axis of rotation. So little r is going to be, okay, it's currently y equals square root of x. but knowing we're going to have to be working in y's,
X squared equals
x equals
y.
y squared. That's what my brain's going to think for little r. Okay? There's one other piece of information we haven't talked about yet.
Bounds.
But we don't have.
We don't have bounds. They didn't tell us.
Jerks. Does that mean we're gonna have to find that intersection point?
Yes, but it's an easy one.
It's also.
First of all, where do they intersect? Right here.
Zero.
Yeah, 0.
That's 0, 0. Piece of cake.
But they
Look at these. X equals square root of y equals x squared. There's only one number that works in all of that.
1.
2.
Or yeah, 2. 1. Whoopee.
I don't know.
What are you saying? 1 second.
Oh, yeah.
One.
No, it is 1.
1.
Because I didn't.
What's the ordered pair here? 1, 1. Think about it. Y equals x squared, 1, 1. The next set after that would be 2, 4, 3, 9. Whereas y equals square root of x is 1, 1, 4, 2, 9, 3.
Oh.
Okay,
Yeah.
now, back it up. That didn't go quite as smoothly as I'd hoped. Could you have set them equal to each other?
Yes.
Yeah.
Definitely. Okay?
It would have been x squared is equal to x squared of x, right?
Yeah, you'd have to work that. Okay, we ready to solve this? Okay, what we got?
Pi. Integral from 0 to 1.
Timeout. Which 0 to 1?
Up and down. The y's.
So officially it's that one there, yes? Just for the record. Because we really aren't answering the, we're just saying, oh, it's 0 and 1 because it's 0, 0 and 1, 1. Okay, 0 and 1. Okay, got it. I'm there. Now what?
Big R minus
Pi. You gotta put in pi.
R.
They had me put up pi up front.
Sorry, guys.
Yeah.
If you haven't put in pi, put in
I
pi.
put in pi.
Square root of y squared minus y squared. In bracket dy.
Okay, are we there? Big R. We decided big R was originally y equals x squared, but then when we solved it, it was square root of y. Little r was originally y equals square root of x. When we solved it, it was x equals y squared, so we're using y squared. Everyone there? Everyone appears to be working ahead without me, so I better catch up. Pi, 0 to 1. I'm going to always clean this up first. Looks so much nicer cleaned up. Now I'm going to integrate. Okay, check against mine when you're ready. Did you just say jazz hands? Are we good? Any careless mistakes we recovered from? Okay, moving along. The favorite thing.
Calculator.
We see a calculator symbol. Remind me to use it when I forget, right? Okay. Which it does at the end say find the volume decimal to 3 places, so. Okay. Find the volume of the solid generated by rotating the region bound by y equals x minus 1 squared plus 2. So what is that?
Top.
That's the top one because that is a parabola that is moved over 1,
Up to.
up 2, yes? Y equals X, which is that right there. X equals 0. What? They don't really mean X equals 0. They really mean it has to be X equals 2. Because about the x-axis, really I need to say X equals 0 and X equals 2, really. So, anyways, about the x-axis, which is this guy right here, yes? So, we did decide this was y equals x, this is y equals x minus 1 squared plus 2, just so I have the visual there. Okay, write the area of a single slice. So, area of a single slice, I probably haven't really talked about that as much as I should. Area of a single slice, area of the circle is what we're looking at. So basically, you're writing it without the dx or dy. Okay? So I kind of just jump right into the volume usually, but area of a single slice is going to be the pi r squared. Okay, so think about it as pi r squared. Except that, is this a disk or a washer method?
Washer.
This is a washer, definitely, right? There's a big old gap again. So since it's a washer, it's not just r squared. Although, you know what? I do have the dx on here. I give up. I don't think I'm supposed to have the dx, but who knows. Okay, area. It's going to start with pi. Okay, let's go back to our graph. What can you tell me?
Is big R the one on top?
Big R, farthest here, yes. So big R is going to be the one on top. I just don't have a good place to write. There's big R. And what's that mean the one on bottom is?
Little R.
There's your little r, yes? Because it's big R and little r. So there's little r, there's big R. Okay, so what are we writing here?
X minus 1 squared plus 2 quantity squared. Minus X squared.
And I think technically the area we should stop there and not have the dx, but
Put the dx gives the height.
because, right, the dx gives you the height, which would be part of the volume. Or I guess it's area of a single slice. And a slice has a height. I don't know. It is, whichever. Write the dx, don't write the dx. I don't know if I meant to write it or didn't mean to write it when I wrote this. Okay. Now,
The integral of that same one thing from 0 to 3.
0 to 2.
Oh, 0 to 2 is for an x's.
are we agreeing with her explanation to herself?
Cubes.
Okay. We are in x's, going around the x-axis, so that's 0 to 2. Now, if we were going around the y-axis, could we agree with 0 to 3? Yeah, we could, but we're not, so. Okay, so volume equals pi 0 to 2. Now it's, so I did my bracket, parentheses, parentheses, x minus 1, parentheses squared, plus 2, parentheses squared, minus, I'm just going to say x squared on this one, dx. Find the volume to 3 decimal places.
Can we just plug that in the calculator?
Yep.
That's so clever.
And technically, I think you could do this one by hand, but
You really want to?
I'm not saying we are. I'm just saying that you could. The hardest part is going to be getting all the parentheses right.
Yeah. Oh my god. When I
Because you have to, unless you multiply that out, you have to get extra parentheses in there.
2, 3. I think I did mine. 3.
What'd you get?
Oh, dang it.
26.389.
3.
26.
Yeah.
What did I do?
Well, I know what I did to begin with.
Ooh.
What'd you do? Put the pie up front?
I forgot it in my calculator.
Oh.
Maybe that was just me, but must be just me because you guys.
I think
are
me and Mario were right.
Yeah.
No.
2, 6, 3, 8. Too much. Too much. We 8.
What's 4 plus 4?
8.
Oh, yeah, that's quite the difference.
I was like, man, I know this isn't the right answer. What did I do? And then I realized, crud.
Oh, she did.
Oh wow, I really
Please, buddy.
did not know what I did wrong.
Reading this in parentheses, that would be my thought.
No,
I
I
think
didn't. Mine were all. I had all lessons.
Okay, or you morphed it to all pluses instead of minuses. Okay, there is really no help when it's those kind of mistakes. You know.
I wrote it all completely wrong here too.
Hurry, hurry, hurry.
Okay.
I hate to be that guy, but I think number 9 just sounds very skippable.
It's all- it's easier.
Okay, you guys got your answer yet? Well, shoot, the answer's up above because I need to erase a screen. Because again, these guys they really need the whole screen. Okay. A solid plastic sphere of radius 5 inches will have a hole bored out of the center with radius of 3 inches. What is the volume of the resulting plastic sphere? Okay.
Danny.
Now, with this in mind, okay, a sphere is the 3D version, right? To put it on this graph, what's the 2D version?
Circle.
A circle. Now, I'm only going to draw the top half. Because what's the whole basis of today? You're going to take that circle and
Rotate it.
revolve it. Okay, so now, well, we're going with it. I'm running out of time here. We're going with my lopsided circle. What do we know about my lopsided circle? It has a radius, radius 5, right?
Yeah.
Goes to 5, negative 5, 5, yes? Now,
Just 3.
I'm not going to think of it as a smaller circle because here's what's happening. That hole that goes through the center is just based on, it's a cylinder, right, that goes through the center. It's just based on cutting out a line. Okay? Now, where is this line at? At 3, because that's going to, so we have this line here that is at 3.
Mine's not even a
That's all right. Okay. And so the idea is, what's the section that's being rotated and making this sphere with the hole in it? Oh, well, the way I have mine drawn, since I drew a horizontal line, I have it this way. Okay, and that's because this the way this hole is shown here. Technically, could we draw it vertical also?
Yes.
You could. Now, big R, little r. Big R is the not parabola, but circle. This is half of a circle.
Oh yeah.
Okay? What's little r? The line. Yes? Now, we need some equations. What's the equation of a circle with radius 5?
X squared plus y squared equals 5.
Alright.
X squared plus y squared equals 5 squared, right? That's when it's centered at the origin. What are we going to need to be solved in terms of here? what are we going to be rotating around?
X.
The x. So that means it needs to be y equals
25
Square root.
the square root of 25 minus x squared.
Yep.
And what's the other piece we're going to have to know? This line is
Y equals 3.
y equals 3, yes? Okay. Interval.
5.
Negative
We need some bounds.
negative 5.
5.
Nope.
0
0
to
to
0 5.
Nope.
35.
5.
Nope.
Um,
0 to 3.
those
Negative 4 to
the
5.
intersection points.
Negative 4 to 4.
Is that what they are?
Those intersection points. In other words,
Oh,
because this, that centerpiece is cut off, is this sphere going to be all the way rounded on these ends? No, it's going to end up being flat. We need to know how far this goes. So it's going to be where those two pieces intersect. And so here's the deal. X squared plus y equals 25 minus the square root of x, y equals 3. Can you set those equal to each other?
okay.
You can.
But
Do
for
we have
lack
a
of time,
calculator sign?
I'm trying to look and see how I did it, and I don't even have it written down how I did it, so.
negative 4. My guess was right.
So it's going to be negative 4, 3, and
4, 3.
positive 4, 3. Right?
Yeah.
And again, that could be done by doing square root of 25 minus x squared equals 3. So 25 minus x squared equals 9. Negative x squared equals negative 16. X squared is 16. And you guys are saying, really, Mrs. Sargent, why are you still doing that? Okay. So interval is going to be negative 4 to 4. You can write it however you want there. We've already talked. Well, yeah, we've already talked. What's big R going to be?
The x squared plus y squared, y equals 25 minus x.
Okay. It's our circle, and it's going to be that square root of 25 minus x squared. What's little r going to be?
3.
It's going to be 3. Okay. You have your information to write the integral, yes? V equals. What am I
times the integral of negative 4 to 4.
And technically you could always do 2 times 0 to 4 if you wanted. Oh gosh. This is why you guys are saying hurry up, Mrs. Sargent. So what'd you do? Square root of 25 minus x squared
Squared.
minus
3 squared.
3 squared
dx.
dx. For your records, 268.083. I don't know if anyone plugged it in, but
I'm like in the middle of it.
if you plug it in later, there you go. Okay. You've got some homework. Try them all, folks. Work on getting the pictures. There's 12 of them. You've got disc and washer mixed in, so. Oh, are we bringing pies tomorrow?
I was gonna bring an apple pie. Is that okay?
Okay.
Yeah, you guys okay with apple pies?
So,
And apple
bring a
pie?
pie. We
I told
will.
Mario I'd try to find a little.
No cinnamon
right for him.
allergies.
Okay, yeah. I would say bring a pie. We can eat some pie.
Yeah.
So save room after lunch, and then we can do some homework questions.
Emma,
so we
I
can
told
do some
Emma that she
notes.
could have a piece. So.
She said, I did half of it.
Yeah, we are.